Welcome to LIPLM's LunchBytes, What's New in Solid Edge ST8, Part 1. My name is Nathan Pfeiffer, and I'm an application engineer with LIPLM. And I appreciate all of you taking out time to join us today. Let's go ahead and jump into our agenda for what we're going to be discussing today. First, we'll cover the Like-Me pattern recognition tool, then synchronous design intent, formerly live rules, the helical curve command, patterning by table, and then finally improving assembly productivity. All of these, I think, are great new functionality inside the software. The first one, again, we'll be covering is the Like-Me pattern recognition tool. This tool can be run on imported or native geometry. It can be run multiple times on the same part. And it can find any collection of faces or any kind of patterns similar to the recognize whole command that already exists inside of Solid Edge. Let's go ahead and jump in the software and take a look at how this new tool is used. You see here we'll use the armadillo assembly today. But I'm going to jump into the sub-assembly of the actual arm. You see here that we have a couple of jaws. And we'll go ahead and open these up. Again, we'll turn off the cover so we can see, and we really want to focus on the gear design of these jaws. You can see that these jaws are working jaws because we're able to move them here. You see how it all works together. You see here that the number 12 has been stamped on the hub of the jaws. That tells us the number of gear teeth, and we'll use that information in just a little bit. In this project, we have another jaw design that was designed in some other CAD system that's been written to a neutral step file that we will open into Solid Edge. You'll quickly notice that with this new gear design, once it opens up, that there's no features currently in Pathfinder. Yet, we need to make specific modifications to this particular part. In order to make changes, we'll need some sort of design intelligence added to it. And this is where the new recognize pattern command comes in ST8. You'll notice that we're able to recognize this pattern, and it even picks up that it's a circular pattern, though some of the instances are actually missing from this pattern. It's a very intelligent tool, and now you'll notice in the Pathfinder that we actually have a pattern feature inside of there. Here again, we'll change the number of gear teeth to 12. As I said, we'd use that information later. And notice that it updates for us, again, knowing what instances to leave out of this particular part. We'll also have it recognize another pattern down here, a linear pattern. This will help us to quickly pick up this pattern, and then again, change the number of instances. Notice that again, pattern 2 was added to the Pathfinder as another feature. And we'll change the instances to 10. Now we'll save this new jaw design and replace the existing left jaw with the one we just imported and modified. When we bring this in, we can choose to suppress any unresolved assembly relationships. We can go back in and redefine them later if we wish to. We'll also bring in a right jaw that we had created earlier and replace it with the existing C one. Now that we have the correct design, we're going to create some quick imagery for product marketing type purposes. For example, here you see that we've added a drop shadow, and that this drop shadow actually updates as we change the model and move the model around as well. It projects this drop shadow onto this virtual floor relative to the orientation of the part on the screen. But we can actually do better than what we just showed, and I'm going to enter key shots which was new in ST7 to actually be included inside the software. And we're going to change how this part looks. We're going to render it better. This keyshot model inside that you see here becomes automatically associated to the Solid Edge model. So that if we have made a change to the Solid Edge model in any way, just with a quick update in keyshot, the model inside of there will change appearance as well. So we'll just drag a couple of different materials and place them on the part. You'll notice as I'm doing this, down in the bottom left-hand corner, there's a keyshot cloud where users like yourself are able to actually upload their custom materials they've created, and you're able to freely take those custom materials and put them on your own parts, as well as upload too if you like. You also see in Keyshot that we have, similar to Pathfinder and Solid Edge, a scene tree, and we're actually able to hide different components of this part, identical to what we do in Pathfinder and Solid Edge. Now we'll add just a few more materials onto this part. We'll paint it a specific color as well. For this example, blue for those jaws that we edited earlier. In Keyshot, not only are we able to control the parts themselves, but we can also define an environment for our part as well. And we'll do that here. These environments include different lighting schemes, virtual indoor, outdoor, and different types of studio environments as well. Here we'll place a simple backdrop for this product. We can also change the lighting characteristics from that predefined environment. Notice here that you can change the orientation and direction of different reflections and shadows by rotating the environments in our scene. Once everything's the way we like it, we can just simply click the render button to create a photorealistic image. Now we enter back into Solid Edge and the main assembly. That was the Like Me pattern recognition tool. Again, it is a very strong new functionality inside of Solid Edge ST8. We saw it used in multiple different ways. In this particular example on imported geometry, but we can do it as native as well. The next tool we're going to talk about is the new synchronous design intent. The design intent interface was previously live rules as you see at the bottom. On the bottom left, you see how it looked in previous versions of Solid Edge, and now on the right, you see that we get a nice little pop-up window with words that tells us the different geometry edits that are taking place. And it's a nice and new intuitive heads-up panel. So let's jump back into the software and take a look at how the new design and intent tools are used. Improvements to the synchronous design intent management enables us to focus on our designs a lot more. Here I'll open up this interface adapter part, and we'll take a look at this new synchronous design intent management tool. As we select the face, notice the heads-up display of the default design intent relationship. Here we also have the help button. If you click on the question mark, it gives us a description of what all is included and describes how the functionality works now. Also, by hitting the play button, it'll give you a video example of the way this works now. This is very helpful when using this tool for the first time. Here you'll notice in this quick video example that the design intent tool picks up a symmetric and coplanar relationship. And just very simply in the box, we can toggle these on and off. It also tells us the keyboard shortcuts, which are the same from Live Rules. Here we'll pick up this face and notice again, it finds a symmetric and coplanar relationship, which again we can just toggle off. Next, we'll add a couple of new features to our design. Synchronous technology makes modeling easier and faster by simply selecting regions of sketches to push or pull to create different features in our parts. In this particular instance, we'll just push it and create a cutout. As we begin to create another synchronous edit, this time a rotation, notice that the default symmetric design intent is maintained and found automatically. In this particular area, there's another face that is parallel to the step above. In Solid Edge ST8, you can anytime invoke an advanced design intent interface where you can enable other relationships that are not turned on by default. Also, moving the design intent panel will automatically pin it to wherever you drag it in the new graphics window, and it will stay there until unpinned or moved again. There's also been a lot of great improvements to enable dragging features that cross over stepped faces to react as a separate set of geometry. Solid Edge will no longer automatically extend those faces, but this, of course, is optional in the quick bar options that you see here at the top. In the past, designers find themselves sketching a line in space and then having to physically move that line and connect a midpoint to a key point location. This is no longer necessary, as you can define the midpoint of a line as the starting point. This is very handy inside of Solid Edge. You'll notice here in a moment that with synchronous technology, trimming the sketch element is no longer necessary. And you see that right here. And once again, we can use the resulting region to define the cut. Creating a line by its midpoint can also be used to automatically build in symmetric design intent. In this particular case, creating a construction line symmetric about the center of the part will ensure that the geometry that we located at its endpoint will be symmetric from one side of the part to the other. The sketch is simply used as a reference point to add the design intent of symmetry. Selecting the checkboxes in the design intent panel is only one of the ways to enable different design intent relationships. As I mentioned earlier, there are also shortcut keys similar to what they were in the past. In this particular example, by pressing A, we can disable the align holes design intent to keep the adjacent holes stationary. You see that right here. For all the geometry that we wish to modify is in the select set, we can simply disable all design intent relationships by unchecking the design intent entry or by pressing the U shortcut key. This ensures that only the geometry that we selected will get modified. Again, this new design intent panel is intended to replace Live Rules as it was in the past. The feeling with development that this is a much simpler way to understand how this functionality works. Now again, we just went over the new synchronous design intent tool, previously known as Live Rules. Its new intuitive heads-up panel and more predictable geometry edits really make this a lot simpler to use. The next topic we're going to cover is the helical curve command. This new tool is easy helical curve creation. You can create lots of different kinds of helixes as well, a constant, variable, or even compound helical curve. And it can be used for other features such as a sweep feature or things of that nature. Now let's go ahead and take a look at this new helical curve command inside the software. Again, we'll start with the armadillo assembly, but we actually want to look and create a soil sampler for the arm this time, instead of the jaws that we were working on earlier. These complex sketching tools like helical curve and the advanced polygon creation enable us to focus on our designs and less on the tool, resulting in a quicker modeling process. The ability to define a polygon, in this case a hexagon, by circumscribing a defining circle using a midpoint of the flat or inscribing the defining circle by its vertex, means that it is much easier and faster to get the desired result with no additional work after creating it. In this particular case, we want the hexagon to be inscribed within the circular edge of the probe base. Setting the option to create by vertex makes this extremely easy, resulting in a region that can be dragged to create a hexagon feature. The sketching tools inside of Solid Edge also make it very easy to define a quick revolve feature to cut away sharp corners on the top of our new hexagon feature that will serve as the base. You notice again that we have open profiles, but Solid Edge is intelligent enough to know that it's just cutting material away outside of that profile. Now we can finish up this feature real quick by adding some simple rounding. As part of this new soil sampler design that we're now going to work on creating, we need to create a complex helical feature that will be used to drill into the earth and extract the soil sample. There are several different ways that we can define an axis, and a starting point for a helical curve. In this particular example, we're going to use the endpoint of the probe and the origin of the base coordinate system to define an axis, and drag along the x-axis to define a random point for the start of the curve. Now you see the new dialog box that comes up. A helical curve can be defined as three different types: a constant pitch, a variable pitch, and then a compound helix. For each type of helical curve, there are three different methods that we can really use to define the curve: length, turns, length and pitch, or pitch and turns. For our particular example, we'll create a compound curve using length and pitch. Adding more defining sections is just a simple click of an insert button. You'll notice here that we can actually drive what this curve looks like just based upon changing our table here at the bottom. The turns then become calculated from these inputs. Our curve definitions may even be saved and reused in other designs, as you see the Save Settings options at the top. So again, we've already kind of created what we'd like to see here. And now all we need to do is simply sweep a sketch all the way down this curve. We'll do this by drawing a circular sketch on a plane normal to the curve. You see how quick and easy we're now able to create a helix of different types as well, creating a compound helix in this particular example. We'll quickly finish this off with a few chamfers. Now, for example, say we'd like to extend the pen down the middle and make this longer. You'll notice that once we do this, our helix automatically updates to lengthen as well. Now again, we finished with the soil sampler, and now we can add it onto our main assembly and see how that looks. This can be done very quickly with the new helical curve command inside of Solid Edge, a very powerful new tool that's included. Again, we just looked at the helical curve command, and we created a compound helical curve. Well, you could also do a variable or a constant helix. The next new tool we'll cover is the pattern by table command. We're very excited to have put this in the software. We're now able to pattern using a table or a spreadsheet in Excel, for example. And not only can we create through the table just a rectangular or circular pattern, we're also able to create irregular patterns as well. And that's the example I'll show once we jump back here into the software, is our ability to create irregular patterns with a pattern by table command. We're also able to link patterns together for the design automation. So let's jump in the software and take a look at the controller for the armadillo assembly that we were looking at earlier. And what we'll focus on here is creating some buttons at the bottom, moving them around, and recognizing patterns on them. Next, we'll go ahead and open up a spreadsheet so that we can begin to take a look, see what this command is able to do. Using a new spreadsheet, we'll define the locations of the joysticks relative to the base coordinate system using PMI dimensions. The blue cells represent the left column of the orange and purple joysticks, and the green cells represent the right column of the red and yellow joysticks. Notice the key waves for the joysticks on the right are rotated 180 degrees from the ones on the left. The positive and negative values represent the positive and negative X and Y directions. Now that we have these values in our spreadsheet, we're ready to use the spreadsheet to define a pattern of cutouts in the front cover of the controller for the joystick. This new pattern by table command in ST8 gives us the flexibility to define the X and Y directions from a predefined coordinate system. It also enables us to define the locations of instances measured from the coordinate system or from the first instance centrally. In this case, the PMI dimensions we used for the locations were from the coordinate system. You can now clearly see how the angle field was used to rotate the keyway of an instance in the right column. As we turn on more parts, notice that there's a soft touch button pad already located on the controller body. Notice that the pattern of buttons is angled instances in the two center columns. This pattern has been defined by a spreadsheet. We want to use that same spreadsheet to define the pattern of cutouts for the buttons in the cover. Similar to the way we pattern the cutouts for the joysticks, we'll use the button location spreadsheet to define the pattern. Note that in this case, the locations of other instances are all being measured from the centroid of the first instance. This is simply handled by changing the option in a dialog box. From the dialog box, we can even open associated spreadsheet if we want to make changes to the instances. As we finish the pattern command, you can see that our cutouts will now match the pattern on the button pad. this case, we need to remove the two middle rows of buttons. Each unique colored cell represents a column in our pattern. Each time the spreadsheet is saved, Solid Edge recognizes the change and dynamically updates the pattern into the Solid Edge model with no required user interaction. By changing the values in the columns, the locations and orientations of the existing instances can be easily modified to get the desired pattern. Instances in a pattern can also be added by adding a row in the spreadsheet. Here we'll add a new button directly in the center of the pattern, and then the same orientation as the instance being patterned. With the new pattern by table functionality, this is very quick and easy to do. Again, you'll notice the unique color of this row as well. And upon saving the spreadsheet, we see that our button appears on the model. As we return to the assembly, we can see that the button pad has not been updated to the changes in the associated spreadsheet. To fix that, all we need to do is open the button pad, and it will automatically recognize the change to the spreadsheet and update the pattern. As you see in these examples, this new Solid Edge ST8 functionality facilitates creation of irregular, highly editable patterns of geometry from a simple spreadsheet. Now to review, the pattern by table command, again, is new in Solid Edge ST8, and we're able to pattern just not rectangular, circular patterns, but also irregular patterns as well, which we showed in the example inside the software. The next and final topic we're going to cover today is the new improved assembly productivity. You now have top-level filters to find files quickly instead of scrolling through many documents. You also have automated missing file replacement with recursive searching. And you're able to reuse top-level sketches for flexible in-context design. Again, these new added enhancements are a huge improvement to Solid Edge, and they were very excited upon releasing this new functionality. Let's take a look at the software and see how this is done. At the beginning of the design stage, a user can now lock into a top-level design without having to scroll through multiple documents. You can simply filter to the top-level assembly. As we open the assembly, you'll notice that a message appears telling us that the assembly cannot locate one of the files. Not a problem in Solid Edge, as the repair missing files will guide you through steps to either find or replace with a different file. The only thing you need to do is tell it where to look, and everything is taken care of quick and easy with Solid Edge. One of the most productive things about working in Synchronous is the ability to grab a face of a part at the top-level assembly to make quick changes. Here we can widen the base of our fixture to make it look more stable, and even use a small offset to get it to fit exactly the way we want it to with ease. Again, you'll notice the new design intent window popped up as well during this process. When working inside a part environment within an assembly, you still have access to all the tools to make your job more productive. Notice how Pathfinder indicates your active position within the assembly structure. In this example, we want to remove material from the base plate to stabilize the stand. Access to other assembly components is crucial to make this result correct. Notice the result after removing material using the top-level assembly components, this approach takes away the guesswork and becomes very productive. Recreating geometry takes time and costs money, so it's important to be able to use geometry already present in your designs. For example, we need to create a relief pocket in our baseplate and remove unneeded features. Here we can grab sketches from the top-level assembly and use them in this part design. After creating the pocket, we can dress it up with some quick rounds and remove sharp edges to finish the part. And now we can enter back to the top-level assembly with our changes in place. Just another productive tool that Siemens has introduced in Solid Edge ST8. This improved assembly productivity will help and increase or decrease your design time, So to summarize what we've talked about here today, the like-me pattern recognition, which can pick up any patterns or faces similar to the recognize whole command, the synchronous design intent, replacing live rules, the new helical curve command, patterning by table, both irregular, circular, and rectangular patterns, and improved assembly productivity with the new tools such as replace missing parts and filtering to the top-level assembly. All of these are great new features inside of Solid Edge ST8. To remind you, what's new in Solid Edge ST8 Part 2 will be on July 30th, 2015. In this part, we'll cover enhanced welding, enhanced drawings, a tool that I'm very excited to show, which is the Drawing Compare tool, enhanced electrical routing and import tools, as well as some digital mock-up tools, and a few other topics that we'll get into as well during this presentation. I'd like to thank you all for your time today, and if you have any questions, please contact me at the information listed here below. Thanks, and have a great day.